All right, my mathematicians. Today we're going to talk about how to differentiate f of x equals natural log x. Mr. Antonucci here, and I hope this is helpful to you. So the differentiation rule for natural log x, I did a video on this of proving what the derivative is, but in this one, I'm not going to rehash that. I'm just going to go straight into the rule. So if you have y equals natural log x, then the derivative is just 1 over x. If you have natural log of some function, let's say it's u, pretend u is a function, not the variable, then y prime, according to the chain rule, is going to be 1 over, oops, almost wrote x there, 1 over u times the derivative of whatever u is, or I like to remember it as just simply u prime over u. Boom. Okay. All right, let's do some examples, because here's the thing. If you have y equals natural log x, there's only so much you can do with that. All right, but how about if you had 3x? Well, then y prime is u prime, which is 3 over 3x, which equals 1 over x. You're like, whoa, what? That's the same thing. Well, let me show you why it's the same thing. If you remember the log properties where you have the log of a product, so here 3 times x, you can rewrite it as natural log 3 plus natural log x. Remember, log of a product you can write as the sum of the logs of the two factors. Notice I put an equal sign because I didn't do any calculus yet. I just rewrote it. So y prime is going to be 0, because natural log 3 is a number, plus 1 over x. And bam, right there, you still get 1 over x. So I did this problem 2 different ways, got the same answer both ways. All right, just wanted to show you that. I thought that was pretty cool. Okay, so now let's say we have y equals natural log of 3x cubed minus 2x. And I want to take the derivative of that. Well, yeah, the first thing you want to do is identify the u. This is going to be the u. And you just remember that the derivative is u prime over u. So I normally like to just write the u first. And then the derivative of u, the derivative of that inside stuff, 3x cubed is going to be 9x squared minus the derivative of 2x is just 2. Now we'll stop here because nothing's going to cancel. You can't cancel these 2's because it's trapped in this subtraction problem in the numerator. You can't cancel an x squared with the x cubed or this x. You can't cancel the 3 and the 9. The only time you can cancel over a fraction is if you have it factored in the numerator and denominator. You can cancel common factors, but we're not even able to factor anything out. You could factor an x out of the denominator, honestly, but that's not going to help you at all. Okay, but I just want to point that out because I see students do this a lot. They do this work, they get it right, and then they start canceling stuff that shouldn't be canceled. Okay, don't do illegal math moves. Okay, how about natural log of the square root of x? I'm going to show you how to do this one in 2 ways. First way I think you're going to like a lot more. The second way you might be like, ooh, that's neat. So remember, square root you can write as 1/2 power. And if you remember, the power rule for log says that if you have natural log of something to a power, you can put the power out front. So you could rewrite this as 1/2 natural log x. So now we can differentiate. So what we have here is a number times a function. And from the basic derivative rules, if you differentiate a number times a function, it's just that number, 1/2, times the derivative of that function, 1 over x. So it's 1 over 2x. Okay, not too bad. All right, let's do it a different way, and I'll show you how you'll get the same answer. Let's say you forgot that power rule, and you wrote that as y equals natural log x to the 1/2. And then you were like, oh, I got to use the chain rule because u is x to the 1/2. Okay, then u prime is 1/2 x to the negative 1/2, which would be 1 over 2x to the 1/2. Okay, that's just the u prime part. So now the derivative, I just did some sidebar work there for you. Remember, is u prime over u. So u prime was 1 over 2x to the 1/2 over u. And u was x to the 1/2. Now, what you have to be careful of here is that the x to the 1/2 don't cancel because the x to the 1/2 is in the denominator of the fraction in the numerator. I know, crazy, right? Well, all you do is, since you're dividing by the x to the 1/2 in the denominator, multiply by its reciprocal. So 1 over 2x to the 1/2 times 1 over x to the 1/2. And guess what that gives you? 1 over 2x. Because when you multiply like bases with exponents, you add them, and half makes 1, so the new exponent will be 1, and you get 1 over 2x again. Bam! Like it, don't you? That's pretty cool. Okay, 2 more. I want to do one with product and one with quotient. So here you have x cubed natural log x. The derivative, talked about the product rule previously, just derivative of the first times the second plus the derivative of the second times the first. So derivative of the first factor is x cubed, excuse me, first factor is x cubed, its derivative would be 3x squared, natural log x, plus the derivative of the second, so that's natural log's derivative is 1 over x times x cubed. So this becomes 3x squared, natural log x plus x squared. Okay? And if you wanted to, you get all fancy pants and factor out an x squared, impress some people. You don't really have to do that. But if you wanted to, that's what you would get. Okay, but this right here is sufficient. All right, one more with the quotient. Let's do y equals natural log x over x cubed. So the derivative would be derivative of the top. So natural log's derivative is 1 over x times the bottom, x cubed, minus the derivative of the bottom, 3x squared, times the top, natural log x. Okay, so just be careful and be neat with your work because you have a lot of weird stuff going on here. All over the denominator squared. X cubed squared, remember, power to a power. When you square a power, you multiply the exponents, so it'd be x to the 6th. Okay, let's clean this up a little bit. This first factor right here, 1 over x times x cubed, is going to give you x squared minus 3x squared ln x all over x to the 6th. Now, both factors in the numerator have a factor of x squared. I can factor that out and write this as 1 x squared times 1 minus 3 natural log x all over x to the 6th. Now, this is where you can cancel this x squared and this x to the 6th and make that an x to the 4th. Because you have products in the numerator and you factored out an x squared, it can cancel with the x to the 6th in the denominator. Okay, one more thing I want to show you about this. Okay, so that would make your denominator x to the 4th. I'm just going to write it here. The numerator would be 1 minus 3 natural log x, but that 3 you could write as an exponent on the x according to the power rule for logs. You can reverse the power rule. And this would be your answer. Okay? All right, guys, hope that was helpful to you. And if you have any questions, if you have any math problems you want me to look over or do, drop them in the comments and maybe I can make a video about it. And while you're here, make sure you subscribe to the channel and hit that bell for notifications so that you know when new videos come out. All right, guys, take care.